Well, thank you so much for having me. I appreciate the time to be here. So I've been in the program since fall of 2023, and I'm delighted to share my final capstone project comparison of property values of contaminated and non-contaminated sites by land use category in Ramsey County, Minnesota. I'll start by outlining my problem statement. Um, so our modern economy requires us to use land for a variety of purposes, commercial, industrial, institutional, and so on. And the use of these properties often results in their contamination or overuse. And those types of contaminations can be a disamenity to the communities in which they're in. Disamenities can be of various types. They could be aesthetic, they can be an unattractive or eyesore. You can have, abandoned buildings and so on. It could be a public health disamenity where you have chemicals or contaminants in the soil or in the air or the water. Economic disamenity, and then that land is no longer available for use or is underutilized and doesn't contribute fully to the community, and is also perceived as a public finance disamenity in that it either back taxes or doesn't generate new property taxes. Here is an example of a brownfield site in my study area. This is in St. Paul, Minnesota. It's a former gas station. It's got leaking tanks. It's no longer an active commercial site. You've got graffiti. It's an eyesore, and it's also this particular site has over 81,000 in back taxes due, property taxes. So it kind of ticks all of the boxes of a disamenity for a community. And so, with that sort of general outline, my specific research question is within Ramsey County, Minnesota, is the per acre value of land containing a record of contamination below, at comparable levels with, or above the value of similar sites without a contamination record within the same existing land use category? And my hypothesis or my assumption is that sites with one or more active contamination record can be expected to have a lower per acre value. And so if I parse out my research question, I can actually begin to determine where I'm going to get my data from and what I'm going to need to use. So my per acre value of land is going to come from parcel data created and maintained by the county. Contamination site data here in Minnesota is maintained by the Minnesota Pollution Control Agency, which is a state agency. And land use data is going to come from my municipal governments because they are the authoritative source for that. So those are going to be my sources of data. So I'll briefly outline my study area. So as I mentioned, my study area is Ramsey County, Minnesota. It is located in the heart of the Twin Cities, Minneapolis-St. Paul metropolitan area. And as you can see from the map on the right, Ramsey County is sliced into 19 individual municipal units, the largest of which is the city of St. Paul, which is Minnesota's state capital. And you can see the major highways that crisscross through there. And also St. Paul takes up about 1/3 of the county's entire area. Ramsey County is interesting in that is the smallest county by area in the state of Minnesota at 170 square miles, but is the second most populous and is the most dense. An interesting thing too, with its population just over 500,000 and Minnesota's population of 5.3 million, essentially 1 in every 10 Minnesotans lives within this 170 square mile area of my study area. So highly urbanized, highly dense, and the most ethnically diverse part of the state. And so to answer my question, I'm going to need to merge data from 3 different levels of government to create a single source to do my analysis on. So I'll walk you through my data and methodology. As I mentioned, 3 different levels of government, 3 different data types, and 3 different data sets. So I have state data for my contamination, county for parcels, city for land use categories. And these data sets were not created with this analysis in mind. They were not really intended or designed for this, and I needed to kind of do some significant work to get them into shape to be able to work together. So I'll start with my contamination data, which comes from the state. These are in the form of points. They're usually associated with an address or some kind of general descriptor. And these are not integrated with county parcels or city assigned addresses or 911 addresses at all. They're kind of live off on their own. I removed inactive sites and non-contaminated parcel points from that data set. I conferred with PCA staff at the state who works with this stuff, and they say, yeah, anything inactive, we maintain the record, but it's not going to be contributing to contamination. And also they said, remove anything that's non-hazardous waste, non-tank, or non-investigation and cleanup. So things like stormwater permits, sanitary sewer inspections, and remediated sites and things like that that are cleaned up, I need to remove from the data set. So I used SQL queries to pull that out, and I basically wound up with 6,933 contamination sites that were eligible for my study. Once that was cleaned up, I took my parcel data and I had to basically do a little bit of filtering on that as well. Parcel data is something that counties produce, and it's essentially an object based on real estate descriptions of each parcel, and it contains lots of fantastic information like its size, its value, its owner, tax classification, and so on. And the map I'm showing on this slide, I've symbolized it in increments of 200,000 to show value per acre, kind of normalizing it with that value there. And you can kind of see in the city of St. Paul, a higher value, and then as you get out, the value per acre goes down a little bit in the northern suburbs. And I had to process that data a little bit as well, removing almost 4,000 non-parcel objects. The parcel data set in Ramsey County carries with it water bodies, which are not actual legal parcels. And it also carries things like road dedications that don't have any data associated with them as well. So those weren't valid for my study. So also in Minnesota, I found out we have one of the most complicated property tax laws in the entire United States. And so I spent a great deal of time sifting through our property tax statute and figuring out which categories apply to owner residential categories and which apply to residential categories, and amalgamating them together. And you can kind of see how most of the county is in owner residential categories there from the map. Okay, with my contamination records taken care of and my parcel records taken care of, I then have my land use data. That comes from municipal governments. And under state law in Minnesota, each municipality has the ability to create its own land use categories and its own zoning. And so I normalize those across the jurisdictions and use the American Planning Association category, color scheme and categories to organize that data and get that sort of standardized across the county. And as you can see from this chart, about 60% of the county is in some form of residential land use there, and then the rest of the county is in the other categories as well. And so my idea would then be I could spatially join these things together and begin to do my analysis work. This part of the work proved to be the most challenging because only 60% of my contamination points actually aligned with the correct parcel. And so I actually had to do a fair bit of work to get that to align. So I have a sample area here in the northern part of the county. The points that have an orange address are contamination points from the PCA, and the points that have that are in blue are the actual 911 associated parcel or correct addresses. The two gold arrows are pointing to contamination points that are actually located on the wrong parcel as that data came over from the PCA. And the three blue arrows are pointing to contamination parcels that are actually located in the right of way and not associated with a parcel at all. And so that's real problematic when you're trying to associate value with contamination. So I'll kind of walk you through how I rectified that. So I've got my parcels. I lay my contamination points on those parcels. You can see some of those fall into the right of way and some are actually on the wrong parcel. And I needed to find a way to associate the contamination point with the correct address. And so I was able to develop a Python script that handled a lot of them, but it didn't handle all of them. And as you can see, about a little over 8% of them, I actually had to manually research them and get them dragged and located into the right spot. The reason for that is there's been a lot of, change over time. The landscape, as we know, is dynamic. And so there were retired addresses that no longer exist, incorrect data, insufficient data. There's parcel splits and mergers. We have a lot of industrial properties being turned into residential properties and so on. And I found a couple clusters as well where there was a whole bunch of contamination points that were just sort of grouped together in the centroid of the zip code. So probably some Friday afternoon work at the PCA and not getting those data points put in the right spot. So that was a real challenge. But once I was able to get that stuff cleaned up, and it took a large amount of work, I was then able to make that spatial join. I was then able to do the spatial join between that data and my land use data. And what I did to ensure that I got clean land use data assigned, because the land use data was a little bit sloppy as well. It didn't always snap to the parcels. So I basically made a centroid of my enhanced parcels, did a spatial join of the land use data, and reintegrated that data back into my contamination parcel data. So I then had my enhanced parcel data set that I could begin to do my analysis on. Creating my super parcel basically with all my juicy data in there with my value and land use and the whole bit, so I could do my work. Also very nice to have the contamination data associated with the parcels, because I can symbolize that instead of having a whole bunch of points all over. I can use the cartography to begin to demonstrate what's going on with the different contamination types across the county. I then did my analysis. One version I split by existing land use. And so the first analysis was sort of yes or no contamination of value per acre by land use category, and then contamination types. I have 8 different contamination type categories that I looked at. And I did the exact same thing, except instead of splitting by land use, I split by the tax classification. And so why don't we take a look at those results? So what I'm showing you are the 10 generalized land use categories, and the value per acre contaminated values are in orange in the box and whisker diagrams, and in the non-contaminated ones are in blue. And the findings from at least this level of analysis was that the contaminated parcels had a higher value than the non-contaminated parcels, which went completely against what I thought would be happening. I assumed that the contaminated ones would be of lower value, except for residential parcels. As you can see, the interquartile range for the non-contaminated parcels is much higher than the other one with its contaminated counterparts there. And also that was true for the very handful of extractive parcels we have in the county. And when we say extractive, we don't have large scale mining in Ramsey County. It's just a few surface gravel pits in less developed areas of the county. So that was an interesting finding. I ran that same analysis using the different splits of the contamination combinations there, exclusive between those 2 categories. And when I lay those out, my assumption was the more contamination categories it would have, the lower its value would be, and that was not the case at all. The black box and whisker, the third one down in each of those categories, I thought would be the lowest because it has all the contamination. That's not the case at all. And I highlight the residential one because you can see its interquartile range is much higher than its contaminated counterparts. And so different combinations of contamination records didn't seem to uniformly lay out or play out in that work. I ran that same thing. Instead of using existing land use, I used the tax classification categories. And an interesting result with this is, again, the commercial, industrial, and tax exempt and institutional lands showed the higher value of the contaminated lands. But here, when I looked at the owner residential categories, their interquartile range is much higher than their contaminated counterpart, but fairly comparable overlap between the interquartile ranges in the rental residential category. So it was an interesting finding, which I'll discuss in my results. And then I did the same analysis, splitting by contamination type by tax classification category as well. And again, the owner residential non-contaminated parcels much higher in value than their contaminated counterparts. But as you can see from that bottom series of box and whisker diagrams down there, the rental ones, their value was, not the non-contaminated ones and contaminated ones have overlapping ranges of those values. So an interesting split from that result. So I'll walk you through my conclusions in looking at this data. So the big one is, except for lands in the residential land use category, the presence of a contamination record on a property does not seem to align with lower property values per acre, as I had hypothesized it would. However, filtering by tax classification revealed that low rental residential tax categories do not align with the lower property value as seen in the owner residential tax category. So that was an interesting finding. The presence or combination of contamination types, either singly or in combination, the hazardous waste investigation and cleanup or tanks, did not align with lower property values other than on the residential land, as I mentioned. And I'm guessing from looking at this and spending a lot of time with it that other factors like parcel size, additional development capacity, proximity to transport, buildings and improvements on the land and their age and condition and severity of contamination would be bigger factors for affecting value. Um, County level analysis for this might not be granular enough. I think it was useful to do an initial first cut, but I think if you're going to do this work seriously, you probably need to do it at a municipal or neighborhood level and get more detailed intel about the sites. And then GIS technology and methods are absolutely vital for doing this. You would not be able to do this by hand researching the title or the records, through a hand done method. You must have GIS technology to be able to layer these things together, even if as crude as these results are. And then finally, this resulting data set will be valuable for folks in our environmental health and our tax assessor and tax forfeit office. They're very excited about being able to use this data for their work. So it hadn't existed before, and I'm glad to have been a part in creating it. So a few considerations for future study. As I mentioned, that split between value and rental residential tax categories and owner residential tax categories suggests there might be an environmental justice angle that might be valuable to look at, and to know where rental properties are and what their past history are and what's been done with them and why they're located where they're at. Again, focusing on a more municipal or neighborhood level, maybe looking at things through the lens of land of the action type or contamination type. So gas stations or contaminated soils or specific breakdowns would be a more useful lens to look at these things with. And then finally, this kind of data set integration between these things really highlights the need for governments to talk to each other. I think all of them would benefit from having access to this data for their work for various purposes, but having to really get things to align and clean them up was a tremendous amount of labor to get that done. So it's an opportunity for them to do that. So, with that, thank you for your kind attention. I really want to thank Dr. Kagankar for his helpful advisement and being available and being fantastic through this whole process, and all of the program instructors through the whole course of work. I want to thank my colleagues Martha and Andra, and thank my wife and my two cats for their support during the entire process as well. And with that, I'm a little over 15 minutes, but I would be happy to field any questions you have on my research. Thank you.